Hey coding pals, welcome back. As you've probably guessed from the title, today we are diving deep into Kotlin Coroutines. A lot of developers either don't fully understand Kotlin Coroutines or they haven't explored them at all. But here's the thing, they are an awesome feature of Kotlin. That's why I have decided to create a tutorial series guiding you from absolute basics to advanced Kotlin Coroutine concepts. So without any further ado, let's get started. Okay, so to understand Kotlin Coroutines, let me take you to a normal function execution. So for this case, we have function A that is going to be called first. But function A has a dependence of function B. Now function B has to execute first in order for function A to proceed. But also function B has a dependency for function C. So for this case, we have to complete first with the function C, printing hello, then we can go back to printing coroutine. And after that, then we can go back to function A and finishing to print hello Kotlin coroutines. For a normal function like this is okay in order to perform executions. But whenever we want to perform heavy task in our thread, then this one is going to be a problem. Let's take a closer look here at how Android applications are actually structured. So basically we have a main thread, and inside this main thread we can perform different things like UI interactions, small operations, and small mathematical operations that can be executed in this thread. However, whenever we try here to use a database operation, for example inserting something, then our Android is not going to be operating because our main thread is going to freeze and our application is going to crash. Okay, so basically the solution here is not calling the database operations inside our main thread. So what can we do? Basically, we can create new threads in order to execute these operations. For example, the database, file uploading, network operations, and doing disk I/O operations here. How can we get the data from these threads? Because we have switched from our main thread and going to background threads. Now, we can use callbacks in order to get the data from these threads. Now here is an example. You can see, for example, we have created here a thread that is going to fetch the data from the server. Now we're just simulating here. Then we can process the data. And after processing the data, basically you can see we have here a callback that after we finish here, we basically call here callback and have the processing data. Then we can say, for example, in database, and basically we have the callback saying, hey, we have finished to save this. We have problem here, which is going to be the callback hell. Basically, you can see we are fetching data from the server, then we are processing data, then saving in database. So you can see we are nesting callbacks after callbacks after callbacks. So this one is going to be a problem for us with using threads. Now let's assume here we are performing again using our threads. Now we have more operations that we want to perform. So we want to create more operations in our threads. And we are going to face another problem here in threads because threads are expensive to create. So we are going to get out of memory exceptions inside our applications. So creating threads is actually expensive. So we have to find a solution managing these threads. So here comes in Kotlin Coroutines. So Kotlin Coroutines are going to help us to manage this because it's just like managing threads. We're creating here a background thread pools that can be used for executions. So we're creating here a coroutine for file uploading, for network operations, and database operations. So you might be wondering, what is a coroutine actually? So the official documentation says that is an instance of suspendable computation. Do you understand it? Hope not. So let's break down these concepts as easy as possible. So Kotlin Coroutines in Kotlin is a lightweight, non-blocking unit of work that allows you to write asynchronous code in a sequential style. So we have seen with threads, we have to use a lot of callbacks. However, with Kotlin Coroutines, we're going to make this sequentially. So you can see the code, you can say this is synchronous and not asynchronous. It's actually a synchronous code that is going to be executed in background. So the key concepts here of Kotlin Coroutines are it's lightweight. So coroutines are more efficient than traditional threads. You can run thousands of them simultaneously and no problems you're going to face. The next case is they are non-blocking. So coroutines don't block the threads they are running on. So we can have multiple threads running in parallel, so they are not blocking each other. So basically we can perform this more efficiently. Another case, we are going to write the code sequentially. So despite being asynchronous, coroutines allow you to write the code that looks synchronous, and linear. So it's easy to read and easier to understand. So the name about coroutines comes from two words, meaning co, which is cooperative, and routines, meaning functions. So we have cooperative functions. So one thing about this is basically the functions are cooperative. So this one is going to help us to actually multitask. So for example, here we have function A that is actually executing to function B, calling function B. Basically, it needs the results of function B in order to proceed the execution. So for this case, we move the control to function B. Kotlin, we have something that is called pausing and resuming a function. Now function B is going to execute, then it can resume to function A. And basically now the control is going to go back to function A. That's why we're saying this is not a blocking, so it's going to be cooperative. They're cooperating between function A and function B. Now function A again is going to need the role of function B, so we can call resume function B. Then function B is going to be executed and the control is going to shift. So this way is going to help us to multitask between different activities in our functions. Okay, let's examine here a simple function that is going to execute Kotlin Coroutine. Okay, so take a moment here and how is this going to be printed? So as you guessed, this one is going to print hello Kotlin Coroutine. So you can see here there is a lot which is going on, so we're going to explain them. So basically here run blocking is a special function that is going to bridge the world of coroutines and non-coroutines in order to execute Kotlin Coroutine inside a main function. So mainly this is going to be used in main functions or test cases. Another case, we have a launch, which is a Kotlin coroutine builder that creates another coroutines, does not actually block the underlying thread. So basically we are launching here a new coroutines that is not going to block the main thread, because you can see we are inside the main function here. So this is just a launcher, and we are going to speak more about this in future videos. The next case, we have a delay function. So a delay is a function that is going to pause or suspend a coroutines without blocking a thread and resume the coroutine after the time elapses. So basically we say, hey, you can use here 100 milliseconds and wait for the coroutine to actually finish, then you can print coroutine. So this is basically the functions. So we are going to explain this in more details in future videos. So if you have not subscribed, please consider subscribing in order to not miss the future videos. Okay, now let's look here at a simple example of Kotlin Coroutine so that it can help you understand. So let's assume here you are going to wash your clothes. So you're going to put inside the washing machine. So you're starting a Kotlin Coroutine. This task is going to take probably, for example, 5 minutes. Now you're also hungry, so you want to go and cook. So you shift from washing, then you go to cooking. Now you're going to set a time. The cooking of food is going to probably take, for example, 20 minutes. Now you say that, okay, the time of washing is actually completed. So you can go back again to drying your clothes. So now you're drying your clothes while the food is cooking and also other clothes are washing. And another, now you say, okay, the time has come, the food is ready, I'm going to take it. Now you can go and eat. So this is essentially a Kotlin coroutine. Basically, there are going to be tasks that are going to be executed. So it's going to help us to multitask. I hope you have understood about the Kotlin coroutine. So let's leave it here for this video. In the next video, we're going to speak about coroutine builders and dispatchers. So if you haven't subscribed, please consider subscribing in order to not miss future videos. So see you in the next video. Bye bye for now.